Hello friends, welcome to my YouTube channel. Now in this session we will continue our discussion on Mahatransco previous assistant engineer electrical solutions. Now the question on the screen is which is from Power Electronics and based on gate characteristics of SCR. So what does the part OY? So here the OY part is there. So what does this part indicates? OY as referred to the diagram in forward characteristics of a thyristor. So normally when you want to turn on an SCR, we should apply some minimum voltage across the SCR, okay, between anode to cathode, that is known as finger voltage. Finger voltage to make the SCR to on. So here OY represents here VG, so it is a minimum voltage required to trigger the SCR. Okay, so this is the minimum voltage required to trigger the SCR between gate and cathode. So this is a VG, so we can write VG here. So VG is the minimum voltage required to trigger the SCR. The next question on the screen is from machines. In drawing the excitation diagram of a DC machine, the field winding will drawn dash to the armature circuit. So it is 90 degrees. Suppose say the armature axis like this, the field axis should be like this. So the angle between these two degrees will be 90 degrees. Okay, so while drawing the excitation diagram, okay, so this is armature flux and this is field flux. So both are having 90 degrees phase shift. So answer is 90. Next one, the losses in a transmission line is 20 megawatts and is loaded at 110 kV. If the load is 200 megawatts and the length is 100 kilometers, then the resistance per kilometer is. So here we are having a transmission line. For example, say this is a transmission line which is having 20 megawatts of power loss and voltage supplying at to a load which is having 110 kV, and that it is supplying a load having 200 megawatts. So friends, here so I square R is nothing but 20 megawatts losses in the transmission line, and so voltage into current is nothing but 200 MVA. So this is MVA. So voltage is how much? So V into I is nothing but 200 MVA. So from this we can find I value. So 200 MVA divided by we can go for voltage is 110 kV. So from this we can find the I value. If you substitute I value here, you will get R value as 6.05 ohms here. So the answer is 6.05 ohms is the answer. The next question here is, a 400 ohm cable has insulation of 3 mega ohms, and what is the insulation resistance for 800 ohms? So the direct formula you can write is R2 by R1 is equal to L1 by L2. So what is the R2 here? R1 here is 3 mega ohms. So 3 mega ohms into L2 is how much? L1 is how much? 400 divided by 800. So 1.5 mega ohms is answer. The answer is 1.5 mega ohms is answer. Next, in electrical circuit with 8 branches and 5 nodes will have, the formula is number of loops is equal to B minus N plus 1. So number of loops here is, number of branches are 8 minus 5 plus 1. So 9 minus 5 is nothing but 4. So here the option is 4 here. So sorry, I didn't mention the option here. So answer is 4 loops here. Next one, which of the following will not be the nature of the torque produced when a DC supply is given to DC series motor is accidentally connected to a single phase supply? That means here we are having a DC series motor which is connected to alternating nature of supply, okay, which is not be the nature of torque. The nature of torque is pulsating torque. So here the option is oscillating, sorry, here the option is OS, oscillating torque. The next question here is, for a three-phase induction motor, the rotor copper losses at a slip of 4% and 625 watts the rotor input power. The relationship you can write here directly. So rotor input is to, so rotor copper losses is to rotor gross mechanical power developed is equal to 1 into 1 is to S is to 1 minus S. Now they have given the rotor copper losses they have given, and we need to find this one. So RCU divided by RGM is equal to S divided by 1 minus S. So slip is 4%. If you are going for RGM is equal to RCU into 1 minus S divided by S. So slip is 4%. If I take 100% here, I can write it as 625 into 1 minus S. S is a 4%. I can say 96%. I can write here 96% divided by S is 4%. So 4 gets cancelled here, and you will get the option as 15 kilowatts. The next question here we have is this question completed. Now next one, which of the following is true for auto transformer in comparison to its two-winding transformer? So auto transformer will have lower losses and better voltage regulation. So these are the two advantages of auto transformers. And the next question here we have is, what will be the daily energy produced in a thermal power plant at a load factor? So load factor they have given it is 0.6 when the maximum demand on the station is 50 megawatts. So we know the formula for load factor. So load factor is equal to average demand by maximum demand. So what is the average demand? So average demand is equal to 0.6 into 50. So it is nothing but 30 megawatts of power generated. So 30 megawatts of power generated. Now daily means for one day 24 hours. So if you multiply this one with the 24, you will get the energy produced per day. So total energy, okay, so energy produced is 30 into 24 hours, you will get 720 megawatt hour is the answer. So thank you friends, thanks for watching. We will continue the remaining solutions in our next session. Thank you. If you like my videos, please subscribe and comment and like my videos. Thank you. Have a nice day. Bye bye.